the top right-hand corner first, right? So remember with bed math, questions are getting more complicated. We're trying to make it smaller by breaking up into parts. So we look for pluses and minuses not inside of brackets. You see any pluses and minuses not inside of brackets. Kalea.
There's one between the 5 and exponent 2 and the 10, and there's an addition between the 2 and the negative 4.
Yeah, excellent. So, remember, according to bed math, that's the very last steps that we're going to do. Adding and subtracting. That means we can break these things up into 3 parts this time. Well, let's do a blue part here, a red part, and a green part here, right? So we just pick a part, we get that down to a single number, then we move on to another part, right? So doesn't matter which part you pick. Our job, I'm going to ask you, which color would you like to do? Blue, red, or green? Green. So what are the math operations here? What do you see? Remember, you got to spot the operation.
Exponent.
Just an exponent, right? So we have this. Let's do it in green. All right. So 4 exponent 2 is not 8. It should be 16. Is it positive 16 or negative 16? Well. So the 2 touches the 4, but not the minus sign. So if we wrote this as a repeated multiplication, the 4 would repeat, the minus sign wouldn't. So it'd be 1 minus sign on the outside or a negative 1 times, right? So this would be a negative 16, right? So we can't forget our day 1 stuff. Negative 16. All right? Excellent. Okay, now we just pick a different color and you just get that down to a single number, right? What do you think, Lucas?
Red.
Red. 10 divided by 2. 5. Excellent. Then we have 5 exponent 2, which is 25. Okay? So we drop down the signs in between. If you end up with a double sign anywhere, like right here, combine those to a single sign. A plus and a minus combine together to make a plus sign or a minus sign. Which one is it? Minus. We're using our multiplication rule, so get rid of that and just do a minus sign. Right? So now adding, subtracting are tied in bed math. So we just go from left to right when we do our calculation. So 25 minus 5 is 20. 20 minus 16 gives us 4. That's it. All right? Excellent. So now, before we go to the back page, you don't have to write these down. You can, but somewhere where you have space. All right. Let's go. I'm going to do 2 questions with you. Let's go. I'm going to do this one in black. Then I'm going to do another one in a different color, looking almost identical. Just right on the top or on the side, or write it maybe right on the back right here. We're not going to do this word statement, so maybe use this spot right here.
Okay.
Let's do, oh, how about I write it there? I'll write it there. Let's go like this. 3 cubed times 3 minus 2 squared times 25. Okay. Evaluate. Yes.
Oh, never mind. Sorry. I had to see the first.
All right. Split it. Where do we split it? So, minus sign right here. So we break it up into 2 parts. We have this part here. Let's do it red. This part here in blue. Then we pick a part and we do it. Which part do you want to do?
Red.
Red. So red. What do we do first in the red section?
Exponent.
Okay. So exponents right? We have 3 exponent 3, which is 27 times 3. And what is 27 times 3? That one is 60, 90, 81. Okay, so now you could have done it just like this, or you could have realized, hey, this is 3 exponent 3 times 3. We could have used an exponent law. This would have been 3 plus 1. It would have been 3 exponent 4. Then you just grab your calculator and go 3 exponent 4 and got 81 as well.
Yes.
Right? So we're at the stage where you can take combination ways, whatever is easier. Sometimes you can use exponent laws. Long as the base is the same and there's a multiplication symbol or a dividing symbol between the things. Let's do that for this side. We could go 2 exponent 2, which is 4. We could do 2 exponent 5, which is, I believe, 32.
Yeah.
All right? But how about we combine these together using our exponent law? 2 exponent 7. All right? Which is, that's a little bit easier to do. Then we grab our calculator. 2 exponent 7. 128. Okay? Then we have that minus sign in between. So do not forget about your exponent laws, because sometimes it makes a question a lot easier to do. So you subtract the two numbers, we get negative 47. Okay? So let's do another very similar question. I'm going to use the exact same numbers. 3 cubed plus 3 minus 2 squared minus 2 to the 5. A split in the middle. And we have our red section. That's a plus. And we have our blue section. All right. Let's start off with the red section again. Can we use our exponent laws here to make that 3? No.
Wait, what's that?
It this is a plus sign between here.
Oh, I thought
So,
it was a multiplication.
right? So we can't use our exponent laws. So don't get in the habit to always use the exponent laws. It's only when they're acceptable, right? They're only acceptable with a multiplication or a division symbol in between. So that's one of the mistakes students will go 3 exponent 4, because they want to do the shortcut way. Right? But you can't do that here because it's a plus sign. So we have to do the 3 exponent 3 like we did last time, which was 27. Now 27 plus 3 this time, which is 30. So same thing on this other side, right? It's a minus sign between those two 2's. So we can't use our exponent laws. So we have to go 2 exponent 2, which is 4, minus 2 exponent 5. We use our calculator, we end up with 32. Right? Then we go 4 minus 32, which is negative 28. Right? Then we drop down our minus sign between these. And we have 2 minus signs right next to each other. So they're going to combine to make a single sign, a plus sign or a minus sign. Plus. Right? So those go away. We make a plus. 30 plus 28, 58. Okay? So just slow yourself down when you're doing these calculations. Say, hey, can I use an exponent law? Can I do the... And just go whichever way you can. Yes?
No.
No, not today. After we do our assignment. So it'll be a quiz next class. Friday, last block. All right?
That's not to move.
Okay. So now, we're going to do 2 questions on the left-hand side here.
What the heck?
All right? This is probably the most common way you're going to do calculation. You'll be given an equation to use. That's this here. And they'll say, hey, use it with this number. All right? So what we do is wherever we see x, we're going to replace it with its value 4. So instead of the x being here, we're going to stick it in with its number. So we have 2, we have a minus 3, we stick in the 4, like so. Now, good, like you said, what? Because something doesn't look right. This is a multiplication. It's 2 times x. So whenever you replace a letter with a number, it's generally very safe to always do it with brackets.
So it's 2 times.
2 times 4, right? So be careful with that. Always put brackets in so it doesn't look like a number 24, right? So now, this just becomes a BEDMAS question. How many math operations are there? 2. There's a multiplication right here and subtraction right there. What do we do first? Multiplication. 2 times 4 is 8. We have the minus 3. 8 minus 3 is 5. Okay. Let's do this one here, but let's change this question to maybe something.
That's too much.
No, it isn't. Actually, just do it as is. Okay.
What?
So now you have 2 letters,
Oh, I learned it now.
but you have each value. So you have x here,
Yes.
and this is where the x goes. You have a y here. This is where the y goes. Okay? So you replace the letters with its value. So our x is 2. So wherever we see an x, we're going to put a 2 in brackets, just like so. We're going to keep everything else the same. Where we see a y, we'll put the y in brackets. There we go. All right. So the hard part of this is not the bad math. The hard part of this is putting the numbers in. Because this is an easier question than what we did earlier today and last day. What's our first calculation here?
Exponents.
Exponents. 2 exponent 2 turns into a 4. Remember, this is 4 times 4, right? Not 44. Carry down the hidden multiplication. We're going to get this down to a single number before we move on to the other parts. 4 times 4 is 16. Then we drop down this stuff. We have the minus 1, we have minus 2. We just do that calculation. 16 minus 1, minus 2, 15, minus 2, 13, and there we go.
Oh, that is easy.
Okay? So don't get fooled by the x's and y's. That's easier. All right. So now this one. Let's skip the top one. Let's do this one. It says not a single power, but it says a value. So you can do it 2 ways.
Yeah.
You can turn each of those powers into numbers and just calculate everything out. Or you can do it as use your power rules. You should end up with the same way. You pick whatever method you want to do. I will do it both ways. Right? So if I did this as a calculation, I would go like this. I would turn that into a number. Remember when we were working with fractions? You get the top down to a single number, you get the bottom down to a single number, then you kind of combine the top and the bottom together. So if I go like this, I go 6 exponent 5 and 5. I'll go like this. That's 777 and a 6. And 6 squared, which is this one, is 36. Right? I'm just going to keep on working the top buttons. All right. So on the top, if I multiply those 2 numbers together, I get 7, 7, 7, and 6 times 36. We get this number, 279,936. 279,936. On the bottom, We have a 6 here. That stays a 6. And we have a 6 cubed. So we go 6 cubed on a calculator.
This is a bit hard.
It is, isn't it? We're going to do it an easier way in a moment.
But why don't we start with these?
Because I want to show you sometimes life can be so much easier if you just look at it a slightly different way. And we multiply those two numbers together. We go 6 times 216 is 1296. Then we divide the top with the bottom. We go 279936 divided by 216, and we end up with 1296. Don't worry, Charlie. We're going to do it an easier way.
Well, I have to do that at some point.
If you don't see the easier way, this is what you're going to have to do.
I'm jealous.
So if we see the easier way, we can clean up the top. We add the exponents. We clean up the bottoms. 1 plus 3 is 4.
That's like way easy.
We combine the top and the bottom together. We subtract. Right? Then we put those together. We should end up with the same answer. 6 exponent 3 216. Wait.
Yes.
Yeah.
Yeah, did I end up with the same answer? Or did I make a mistake on the other side?
The second one was way easier.
Yeah. You should end up with the same answer. I don't know why. Oh, that's why. I made a mistake when I was dividing the first one. 27,999,316 should have been divided by 1296. Sorry, that was my fault. They both end up with 216 here. All right? So, my whole point of this is not to make you guys do the hard stuff. Is to spot sometimes there are easier ways. Now, one of the things that sometimes we get students really messed up with is sometimes you'll be given a question, and it happens a lot in grade 9. It happens even more in grade 10, is they'll give you a very complicated bed mass question. They'll go something like this. I don't know. Minus something like this. They'll make this huge thing. So you got to do your brackets first. Right? But if you look very carefully, this is a very easy question that you should be able to answer it in less than a second flat. What's the answer to this question? Does anybody see it?
Wait, what?
6, 7.
No. The answer to this question is 1.
What?
What?
Huh?
Right? Sometimes pay attention to the very last step you're going to do. The very last step you're going to do is this. The exponent 0. So it doesn't matter what the base is. It's going to turn to 1. So watch out when you have exponent zeros somewhere in the question. That can help clean things up so much faster. You can spend 5 minutes doing the stuff inside, but then you have the exponent 0 at the end. It doesn't matter what the number inside was. The answer just becomes 1. Right? So things to watch out for.